In this lecture, we will learn about the abstract factory design pattern and how to implement it in Java. Abstract factory is a creational design pattern. It allows us to design a superfactory that creates other factories. With this pattern, we provide interfaces for creating families of related or dependent objects without specifying their concrete classes. We can say that the abstract factory is a factory of factories. Each generated factory can create the objects as per the factory design pattern, which we will learn about in a few lectures. When do we use the abstract factory design pattern? We use the pattern when our code needs to work with various families of related objects, but we don't want it to depend on the concrete classes of those objects. They might be unknown beforehand, or you simply want to allow for future extensibility. In a well-designed program, each class is responsible only for one thing. When a class deals with multiple object types, consider using the factory or abstract factory design patterns. To implement the abstract factory design pattern, we first map out the objects and variants of objects. Then we declare abstract object interfaces for all object types. We then make concrete object classes implement these interfaces. Next, declare the abstract factory interface with a set of creation methods for all abstract objects. Then we implement a set of concrete classes, one for each object variant. After that, we write the factory initialization code. Then anywhere we were going to call the product constructors, call the appropriate creation method on the factory instead. Let's look at the pros and cons of using the abstract factory design pattern. On a positive note, objects created by a factory are compatible with each other. It avoids tight coupling between concrete products and client code. Code using the abstract factory pattern follows the single responsibility principle, where each class does one thing and does it well. Using the abstract factory pattern, we can introduce new variants of existing objects without breaking existing code. The drawback of using the abstract factory design pattern is that the code may become overcomplicated with lots of new interfaces and classes. Now let's learn how to implement the abstract factory design pattern in Java. We will create an interface named iMobile, which will contain two method signatures. The first will be named getAndroidPhone that returns an iAndroid. The second will be getIOSPhone that returns iOS. Next, we will create a class named Samsung that implements the iMobile interface. This function will implement the public iAndroid getAndroidPhone method, and inside of it we will return a new Samsung Galaxy. Then we will implement the getIOSPhone method, inside of which we will return a new Samsung Guru. After that, we will create an interface named iAndroid that contains a method signature for a method named getModelDetails, which returns a string. Then we will have an interface named iOS, which contains the method signature for a method named getModelDetails that returns a string. Next, we will create a class named Samsung Galaxy that implements the iAndroid interface. Inside of this method, we will implement the getModelDetails function, and inside of this function, we will return a string that specifies the model as Samsung Galaxy, RAM of 2 GB, and camera of 13 MP. Then we will create a class named Samsung Guru that implements the iOS interface. Inside of this class, we will implement the getModelDetails function, inside of which we will return the string Samsung Guru, RAM NA, camera NA. Next, we will create a class named Mobile Client. Inside of this class, we will have a variable of type iAndroid named AndroidPhone, and a variable of type iOS named iOSPhone. Then we will add a constructor for this class that takes in one parameter of type iMobile named Factory. Inside of the constructor, we will set AndroidPhone equal to factory.getAndroidPhone, and iOSPhone equal to factory.getIOSPhone. Then comes a public method named getAndroidPhoneDetails that returns a string. Inside of this function, we will return AndroidPhone.getModelDetails. Similarly, we will have a public method named getIOSPhoneDetails that returns a string, inside of which we will return iOSPhone.getModelDetails. Time to test our code. Inside of our example class, we will add Java's main method. Then we will create a variable of type iMobile named Samsung Mobile Phone and set it equal to a new Samsung object. After that, we will create a mobile client variable named Samsung Client, which we will set equal to a new mobile client with Samsung Mobile Phone passed in. Then we will print out Samsung Client.getAndroidPhoneDetails, followed by Samsung Client.getIOSPhoneDetails. When we run the code, you will notice that the details for both the Android and iOS Samsung phones were printed, meaning that our code worked. In the next lecture, we will learn about the builder design pattern and how to implement it in Java.